Okay. The next operation of binary search trees is searching. Okay, for searching of a node, we can write the code like this. Okay, first we'll search whether the tree is null or not. If it is null, we'll return the null. Okay, if the tree is not null, then we'll check whether our element is less than the tree value or not. If it is less than the tree element, okay, then we will call the same function again with the x as the x is the required value to be searched and t of left, that is left subtree of the current node. If the x value is greater than the element, okay, then we will pass the required value and right subtree of the tree. Okay, so once if all these conditions are false, that is nothing but that x value is matched with the tree element. Okay, then we will return the our t node, that is the node which is matched with the our value, that is returned from the find function. Okay, this is a simple code for searching of a value in the tree, binary search tree. Next, so inorder traversal of the binary search tree. So this traversal is similar to the binary tree traversal. Okay, first we will traverse the left subtree. Once after completing of the left subtree, we'll print the root node value. Then we will traverse the right subtree. Okay, okay, this is applicable for the each and every node. Okay, if the node has the left subtree, we'll move on to the left. Okay, then we will move on to the next node until unless we reach to the leaf of the left subtree. Okay, once we reach to the leaf of the left subtree, okay, then we'll print that particular node, then go back, that is backward to the parent node. Okay, and then we'll print the parent node value, then we'll traverse to the right. Okay, like this we'll repeat for the each and every node in the binary search tree. So whenever you traverse the binary search tree in the in order traversal, then you will get the ascending order values. Okay, because the left leaf of the binary search tree is the minimum value of the that particular tree. So starting from the last first leaf of the left subtree to the last leaf of the right subtree right side. Okay, until that we will traverse. Okay, so that last value of the right subtree is the maximum value in the tree, and first leaf of the left subtree, that last leaf of the first left subtree is the minimum value of the tree. Okay, from this value and to the right subtree value will print, so that it gives the or in order traversal gives the sorted order of values. Okay, next. Okay, another operations in the binary search tree are the finding a minimum value, finding the maximum value. These two will generally use within the deletion operation of the binary search tree. Okay, so finding the minimum or maximum. Minimum is we will find from the left subtrees, and max is we will find from the right subtrees. Okay, so for the minimum, we can see the simple code is like this. If tree is null, return the null. If tree is not null, okay, then we will repeat until unless the left is not equals to null. If once you reach to the left in null, then we'll return that node. Okay, so that is once you reach to the left subtree last leaf, then we'll return that last leaf node value of the tree. Okay, until unless we'll call the find min function with the t of left. Okay, the same function you can change to the maximum as t equals to null, return null. T of right equals to null, return t. Return find max of t of right. Okay, like this you can change the find min and find max functions. Okay, these are to find the minimum value in the binary search tree and maximum value in the binary search tree. Okay, these programs, these code snippets you need to remember to write in the exam point of view. Okay, these are not in your lab record programs. Okay, just remember whenever whenever it is asked in the exam, like to find the minimum value or maximum value, then you need to remember these. Okay, so for that you can just revise these two. Next. Next, for in the insertion of a node in a binary search tree. Okay, we generally insert a node in the binary search tree at the left or at the leaf of the binary search tree. Okay, this may be at the left or right of any particular node. Okay, based on the value matches with the node values. Say for example, I want to add a one value. Okay, if it is greater than that node, then we'll move on to the right subtree and we'll check with the another node. If it is less than the another node, then we'll move on to the left of that. Okay, again we'll check for the node. Okay, if it is less than the node, then we'll go into the left. If it is greater than, then we'll go into the right. Okay, if it is less than the node value, that is if the your value is 13 and that is less than the 15, and we'll also check whether there is a left subtree for the 15 or not. So here there is no left subtree, so we are adding the 13 as the left of the 15. Otherwise we'll move on to the until unless we'll get the left as the null or right as the null to add our node. Okay, next. Okay, for the insertion, this is a small snippet of a code. So insert function has the two parameters. One is the value to be added, that is x. Another one is the root node. A root node or a tree root node. Okay, binary node t. So if t is equals to null, if that passed root node is the null, then create a one new node. Okay, create a one new node with the malloc, and will pass the x is our value. Okay, these two are the null. It's actually using another code. Okay, this is only a pseudo code. Okay, just remember that here we are creating a one new node and that is assigned to the t. Okay, so if t is not equals to null, okay, then we'll check whether the x is less than the node value. Okay, if it is less than the node value, then we'll call the same insert function with the x and t of left. If the x value is greater than the element, greater than the node value, then we will call the insert function with the x and t of right. Okay, like this we will repeat until unless we'll reach to the leaf. Okay, when it becomes a null, whenever we reach to the leaf, then t will be the null. Okay, then we'll create a one new node and we'll attach it to the tree. Okay, next for the deletion. Okay, this is also you need to just remember, this is not actually in your lab records. Okay, just remember the how the deletion is performed in the binary search trees. So deletion is nothing but we need to remove one node from the tree. Okay, so here in the binary trees, the node may be a parent or maybe a child node or maybe a leaf node. Okay, so that we can check, we need to check whether the node is a parent node or a leaf node or a child node. Based on that, we can delete the node. Okay, and at the same time, whenever you are deleting the nodes, we need to take care of the child nodes of the node. Okay, so there are the three cases in the deleting. The first case is the deleting a leaf node. So leaf node, say for example, I want to delete the 3. Okay, if the node 3 is to be deleted directly, we can delete it. Just we can replace this node value as the null so that it is deleted. Okay, say if you want to delete a node that has the one child. Okay, say for example, I want to delete a node is the 4. Okay, 4 is to be deleted. Okay, 4 has a one child, that is in the left subtree, it has a one child is the 3. So this is added as a child of the 4 parent. The parent of 4 is 2. So for that we will add this 3 as the child node. Okay, okay, so that we'll make a link from the 2 to the 3 so that 4 is deleted from the memory. Okay, next third case is the delete the node which has the two children. Okay, so either it is having a both right and left childs. Okay, if you want to delete the node which has the both left and right childs. Okay, then what we'll do is either we can replace the node value with the minimum value of the right subtree or the maximum value of the left subtree. Okay, say for example I want to delete the 2. So this 2 can be replaced by the minimum value of the right subtree. Okay, from the right subtree you can take a minimum value and that is to be replaced by the 2, or you can take a maximum value in the left subtree. Okay, we can find a maximum value in the left subtree and that is be replaced by the a two node value. Okay, so here it is using this example is using a minimum value from the right subtree. From the right subtree, the minimum value is the 3. So 3 is replaced by the 2. So now we need to delete this node, this 3 node to be deleted. Okay, so that this 4 is attached as a child to the 5. So the 3 is deleted from the memory. Okay, okay, this is the deletion operation. Okay, okay, there's a code snippet for the binary search string. Okay, and just prepare the code as per the code which is posted you in a previous video. Okay, just enter the total code in your online editors or in your code blocks window and execute that uh, and note down the result of that. Okay, okay, this is a very binary search trees is very simple code. Okay, you can learn it easily. Just you need to remember the any one of the traversal so that you can exchange the statements and it becomes a three traversals. And you need to remember the insertion code. Okay, that is also very simple. Whenever you are using with the recursion, insertion code is very simple. Okay, so just 4 lines of a code or 3 lines maximum, it's a 3 lines code only. And in order, pre-order and post order is also three lines code. And you have the main program. Okay, with the three with the out of 10 lines you can complete the main program. And you need to create a one structure. Okay, the three traversals, insert and main function, these four you need to remember. Okay, and other than this you didn't require any binary search tree code more than this. Okay, so this is our fourth unit is completed with the trees, binary trees and binary search trees. Okay, prepare well. Okay, if you have any doubts, please send me the doubts. If you require any revision of the any topic, I will revise you back. Okay, just post me a message, I will revise the topics.